message size to the object A and return some value. There's also an arithmetic form of this, and here's a compound statement, A size plus 5. This would be accomplished by sending the message size to the object A, taking the resulting value that comes back and sending the message plus 5 to that. And then for larger procedure calls, if you will, that have several parameters, you can comprise a message in the following way. This reads as A plus 5 between 0 and Q top. That would be evaluated by sending the message plus 5 to A, getting some result, and that result would be sent the message between and with two parameters, 0 and the top limit, Q top. And this syntax with the keywords and with putting the receiver at the beginning reads a little bit like English. And if you look at something like a music system that's been built in this way, you find statements that read very naturally as kind of a micro-language having to do with music. For instance, this statement, instrument, play this note for that duration. So for a little bit of terminology, we have objects, and they're described by classes. That just sort of factors the description of what the objects consist of and what they're capable of doing. Then we have messages, which are being sent, and we call the part of the name of the message the selector, and the message is the selector plus whatever values are being passed along. And finally, we have methods. These reside in the classes, and they are the specific code for how to carry out the request implied by the message. Now, to see how this works in just a simple kind of object, we'll consider how you'd model XY coordinate pairs, which in Smalltalk would be called a class point. The first thing in the class describes what fields are in a point, namely there's an X coordinate and a Y coordinate. These are local variables in each instance of a point. And here is a brief excerpt from all the messages that are understood by points and the code that is invoked, the methods that are invoked if sent that message. So this first one is X colon Y colon, which allows you to store into the variables inside of the point with a new X and Y coordinate. If you send a point the message X, then it will return its X value. If you send it the message Y, it will return its Y value. If you send it the message plus and another point, then it will create a new point, sending new to the class point, which will make up a new one, a blank one, and initialize it with an X coordinate, which is this point's X, plus the other point's X, and a Y coordinate, which is this point's Y, plus the other point's Y. So this is just a short way of doing sort of vector addition of these two coordinate pairs. And this last message down here would divide a point by a certain scalar value. Creates a new point and whose X coordinate is divided by n from this one, and whose Y coordinate is scaled down by n as well. Having made this description, we can now build up rectangles from these points. Here's a model for a rectangle, which has two fields in each object. It's a point describing its top left corner and a point describing its bottom right corner. And there would be a couple of messages in this class, top left to return the top left corner, bottom right to return the bottom right corner. And now you can see how the capabilities that we gave to points allow you to do interesting things very simply. For instance, you can ask for the center of this rectangle, for which there's no stored value. And it will invoke this method here, which says return the top left plus the bottom right divided by 2. And those messages will invoke the similar code back in class point to return a point whose coordinate is the arithmetic mean of these 2 points, which will in fact be the center of that rectangle. So we're building up a little sort of a graphical micro-language here. It's really just a set of procedures, but they can be described very tersely in this manner. Now let me just show you how this works inside the machine, as it were. The rectangle is a little piece of storage, and it has a pointer to its class. And it's in the class that the information is stored about what fields it has. It says it's got a top left and a bottom right. And these names correspond to the slots in every little rectangle, which is a piece of storage. There's also a pointer here from the class to an object called a method dictionary, and it correlates the names of the messages being sent, the selectors, with the code, with the methods for returning the appropriate values. So here's top left, and there's the method that says return top left. Here's an entry in the dictionary under the name center, and it points off to the method that we just examined for calculating the center. And these structures are put together recursively, so the point for the top left points to another Smalltalk object. This one is an instance of class point, so it would point off to some description of class point in its first field. And that would tell you that this is the x and the y. And this other point is just the same way, except it has different values for its x and y. Now, having put all those things together, it's now possible to produce considerably complex simulations without running into the problems we had by mixing different similar interacting data types. But there's still some problems. When you want to go describe a new class of data, you have to write the whole thing from scratch. And also, you'll find many places where there's the same kind of code. For instance, if you're talking about collections, you might have arrays, and you might have character strings, and you might have dictionaries, and you'll have similar code for doing, say, selecting all the elements for which such and such is true. You'll have to have copies of that code in all those classes. So once again, you're into a problem of you can build more complex system, but once again, you start running into one of these limits of just how complicated things are. And the way for dealing with these problems is, again, to try to simplify and yet make things more general. And the concept we have to take advantage of here is inheritance. Inheritance is very simply put into the implementation I showed you by having a chain that goes from a class up to another class from which it will inherit behavior. That way, if you send a message to this object and it's not found in the method table for this class, then it will go and look in its superclass and see if there's a definition for that message here. And this continues on up all the way to a sort of a default superclass which describes the general properties of all objects. Now, what the inheritance allows you to do is to save a lot of code. Here's an example of factorial. And here's a simple description for how if you send a message factorial to an integer, then it says, am I less than or equal to 1? And if true, if that's true, then return the result 1. If it's false, then return myself minus 1's factorial multiplied by myself. So this is a recursive definition of factorial. Now notice that it's defined for integers. And here, integers inherit the properties of all objects. And these might be simple things about how to print themselves. But the properties defined in integer are inherited both by small integers, which may be compact and have particularly fast operations, and also by large integers, which may have a greatly extended range of values. So if you ask to compute the factorial of 20 or something, it will go through this calculation. Let me just show you how this inheritance works. Both of these classes here will inherit from class integer. Now what's interesting is when you actually invoke this code, running something like factorial of 20, there will come a time, these will start out being small integers because 20 is a small integer, but there will come a time when the factorial of the number that's smaller will actually be a large integer. And we have here an asterisk implying multiplication. In most programming languages, most conventional programming languages, it has to be known what the types of the integers are on both sides. But because that is simply a message, it's just the name of an operation, this code will work regardless of whether the receiver is a small integer or a large integer, or some completely different kind of integer that you defined. So there's a kind of a symbiosis between the inheritance that's available in the system